In our continuation with hardware of a PLC, we will now be discussing application memory. The application memory is divided into two: the input table and the output table. The input table is an array of bits that stores the status of the digital inputs connected to the PLC's input interface. The maximum number of input table bits is equal to the maximum number of field inputs that the PLC can be connected. While an output table is an array of bits that controls the status of the signal of the input-output devices that is connected or that are connected to the PLC's output interface. The maximum number of bits available in an output table equals to the number or maximum number of the output field devices that could be interfaced with the PLC. To further illustrate such input and output table, here is the following illustration. In a particular input table, and we have a limit switch that is connected to the input module, and the limit switch is a normally open one, so it means that the status at which the limit switch is connected to a terminal 7 of a PLC would read a 0 status in the input table. But once the limit switch has been closed and turned on, it will send a signal to that particular point in the input module, which sends the signal to the input table telling that the input table 07 at address 07 has turned on. It only goes to show that also in the output, if in the program the output is being triggered at address 05 and it's been triggered as the output is equal to 1, it will send the signal going to the output terminal at address 05, making the lamp turn on. While, let's say for example, in the program, the address 05 has been turned off. So it will be sending a signal to the output module address 05 in the PLC, making the lamp turn off. Moving further, we have what we call input-output modules. The input-output modules connects the PLC to different inputs such as sensors, push buttons, and switches, and outputs such as actuators like motors, solenoids, lamps, etc. It provides isolation for the low voltage, low current signals that the PLC provides, and that is internally from a higher power electric circuit that requires by most sensors and actuators. Wide range of I/O modules are available, including digital and analog I/O modules. Input modules are modules on which inputs come from sensors that translates physical or chemical phenomena into electrical signals. The simplest form of inputs are discrete or digital, which means ones and zeros, in either forms of voltages, whether that would be AC or DC. In smaller PLCs, the inputs are normally built in and are specified when purchasing the PLC. But for larger PLCs, The inputs are purchased as modules or cards with 8, 16, 32, 64, or 96 inputs of the same type on each card. The list below shows the typical ranges of input voltage. What does it mean? These are the voltage signals that the PLC could receive and can handle. Please take note that not all of these voltages are acceptable to a PLC. It depends on the PLC manufacturer or the type of PLC that you are using. Such ranges of voltages are the following: 5 volts DC, 24 volts, either AC or DC, 48 volts AC or DC, or even as high as 110 volts AC, 220 volts AC or DC. Analog outputs or inputs or outputs are what we call analog to digital or digital to analog converters. This converts the signal voltages, whether from the sensors, and translates it into bits of data on which the PLC could understand. Its resolution can be important in choosing the applicable card, whether that the size of what we call the number of bits that is acceptable in an analog input and output could be acceptable to the main CPU of the PLC, whether that would be either 8-bit, 16-bit, or 32-bit. Typical analog input signals are the following: flow sensors, humidity sensors, pressure sensors, temperature sensors, or even vibration. If you would notice, these kinds of sensors are being used in our industrial process control. An analog output signal controls are analog values such as, let's say for example, dimming of lights, to as high as variable speed drives that controls the speed of a particular motor. Typical ranges of signal levels are the following: instrumentation purposes such as 4 to 20 milliamps, 1 to 5 volts DC, 0 to 10 volts DC, and negative 10 to positive 10 volts DC. So this will be our last lecture for this module. We will be seeing you again on our next module, so stay tuned for the next